if you read the question, it states that there is something called saltpetre, and it's a mineral found in Peru, and it consists of sodium nitrate. So the first thing is we're dealing with sodium nitrate over here. So it's got something to do with that, and the mineral is purified to concentrate the sodium nitrate, which is used as a fertilizer in some fireworks in order to find the purity. So you're looking to find the purity of this sample of sodium nitrate. That's the goal. So the purity of the sample of sodium nitrate, that's got to be found. The compound is heated in NaOH and Devarda's alloy, which contains aluminium. So here's the reaction that's going on, and this reduces sodium nitrate to ammonia. So you've got your sodium nitrate over here. It's heated with Devarda's alloy, which contains aluminium, and it's heated with NaOH, and you get ammonia. Now, it then states that the ammonia gas produced is dissolved in an excess of H2SO4 of known concentration. So the ammonia gas that's produced over here, it's taken, and another reaction is done. It's reacted with an excess of H2SO4. So remember, focus on this, that there is an excess of H2SO4. And then it states that the amount of unreacted H2SO4 is then determined by back titration with NaOH of known concentration. So you've got an excess of H2SO4, the amount of unreacted H2SO4. So the H2SO4 that did not react in the previous reaction is now, its amount is determined by back titration with NaOH. So this is what's happening. There are three reactions involved. You took sodium nitrate, which was an impure sample. Ammonia gas was produced, and that ammonia gas was then dissolved in an excess of H2SO4, and there would be some unreacted H2SO4. This is the unreacted H2SO4 from the previous reaction. So the amount of unreacted H2SO4 was then reacted with NaOH. So now we have the values as well. You've got 1.64 gram sample of the impure sodium nitrate. So remember, this is 1.64 grams, but it is impure. And it was reacted with an excess of this and dissolved in 25 cm cube or 1 mole per dm cube H2SO4. So can you even tell me what the moles are? If you do concentration times volume, how many moles is that? 25 divided by 1000 into 1. So you're getting 0.035 or 0.025. So we're getting 0.025 moles of this. So the ammonia produced was dissolved in this H2SO4. And remember, that's an excess. When all of the NH3 had dissolved, the resulting solution, which is the leftover H2SO4, was then reacted with NaOH. And the amount and the concentration of NaOH is also given. So you can find the moles of NaOH. So after all the ammonia had dissolved, the resulting solution, which contains the unreacted H2SO4, needed this much NaOH. So what is that amount? It's going to be, moles is concentration times इसका क्या आ रहा है? What is the amount of moles that we're getting?
0.0324.
नहीं, 0.0324. So हो सकता है 0.0324. So it's 0.0324 moles. So I converted all the data into moles. I couldn't convert this into moles because this was an impure sodium nitrate. So you can't do that because it's impure. You don't know what the mass of sodium nitrate is. So this is all that's going on. 1.64 gram of this is dissolved in NH3. That NH3 is then dissolved in 0.025 moles of H2SO4, and wo jo bach gaya na, the leftover H2SO4 is then taken and reacted with NaOH, and you know the moles of NaOH as well. So this is all that is given. So the first part is calculate the amount in moles of H2SO4 present. We already did that. The next part is calculate the amount in moles of NaOH. So we did that as well. Now he's saying use your answer to calculate the amount in moles of H2SO4 that reacted with NaOH. So we can do that. It's 2:1. So if NaOH has this many moles, H2SO4 moles would be what? What would be your answer? It's going to be divided by 2. What do you get if you divide by 2?
0.0162.
So we get 0.0162 moles. अच्छा, अब उस अगले part में he's asking use your answer to calculate the amount in moles of H2SO4 that reacted with NH3. So he's asking okay, what is the amount of H2SO4 that actually reacted with NH3? So this is the amount that was added, right? And this is the amount that is still left at the end of the reaction. So if you added 0.025 and 0.0162 is left, and that leftover 0.0162 is then reacted with NaOH, what is the amount that actually reacted with NH3? So 0.025 subtract 0.0162 from it. So what do you get
So
for that?
8.8 into 10 raised to power minus 3.
कितना है? 8.8
into 10 raised to power minus 3. 8.8 into 10 raised to power minus 3.
So we're getting 8.8 into 10 to the power minus 3 moles. So we got the moles of H2SO4 that are actually reacting with NH3. Again, remember, okay, 0.025 was added, but he clearly mentioned it was added in excess. 0.0162 was still left, and it was taking part in another reaction after the first reaction. So this is the amount or quantity that was left after the first reaction. So that means only 8.8 into 10 to the power minus 3 moles got used up with the reaction. And you can now find the moles of NH3. Next part, he's going to ask you for the moles of NH3. So you found the moles of H2SO4, the moles of NH3 would be twice that. So what is twice this?
0.0176.
अच्छा, तो NH3 के moles आ रहे हैं 0.0176 moles. So you found the moles of NH3 now. And once you've found the moles of NH3, I mean, he's then going to ask you about the moles of sodium nitrate. So first thing, you found the moles of NH3. Where did all this NH3 came from? It came from the previous reaction. One thing you should never do is never compare the ratio of this equation with this equation. Okay, make sure you don't do that. The ratios that are given over here, 3 and 18 and 5 and 8, etc., they are ratios between them. It's not a ratio between equations. Okay, make sure you remember that. यहाँ पे ratio नहीं लगाना कि this is 2 and this is 3. It's not a ratio. I mean, this coefficient over here is a ratio with the other reactants and products in the equation, not with some other equation. So make sure you remember that. Now this NH3 was produced, all these moles came from the previous reaction. So all this 0.0176 moles were produced in this previous reaction. So it came from that. So all this NH3 that you have over here came from the previous reaction. So it's 0.0176 moles of NH3 that were produced in the previous reaction. And its ratio with NaNO3 is the same, 3:3. So that means the moles of NaNO3 are going to be exactly the same. So you found the moles. And the next thing is they're going to ask you for the mass. So you can find the mass now. It's moles multiplied by the MR, which is NaNO3. क्या होगा? 23 plus 14 plus 16 into 3 is 48. So what is the mass that we're getting?
Uh, 1.496.
Okay, so we're getting 1.496 grams. The impure had a mass of 1.64 grams. So the purity is going to be 1.496 is pure over 1.64 out of 1.64 times 100, and that will give you the percentage purity, which is going to be what? 76? Yeah, yeah.
191.22.
That's 90. 91.2.
Double
Look,
two.
so you'll just write 91.2. You can remember your answer cannot have more significant figures than the values that you're using. Your answers cannot be more accurate than that. Okay. So everywhere it's these significant figures, your answer it can't be more accurate than that. So anyways, the takeaway from this is make sure, remember this, okay, the ratio of one equation is the ratio between the reactants and products. It's not the ratio with some other equation. Okay, make sure you remember that. The ammonia that was produced over here, all of that came from the previous reaction. So if there's 0.0176 moles that is reacting in this reaction, all of that came from the previous reaction. So in the previous reaction, 0.0176 moles were the ones that were produced. So is this clear, this question? You clear it, yes or no? No, Aisha, okay. Now, so now let's do more of these. Okay, so remember you can have multiple equations and reactions that could be involved. And remember in the structured paper, ये कितने marks का था? I think it was still 10 marks. So let's try and do this one. Now this one is also slightly tricky because I mean, remember you have to understand the story, because the rest of the most part, comprehension is the thing that you have to work on. 50% of the question is all about understanding the question. The moles part is easy. You find the moles of one thing, you just by just using ratios, you can find the moles of all the other things. But comprehending the question, that's more important. So there's a 2.96 grams. So there's a fertilizer that contains ammonium sulfate. So that's what it has. I can, let me just add it over here. So there's a fertilizer. Okay, so the question states that there's a fertilizer and it contains ammonium sulfate. And then it states that there's 2.96 gram of the solid fertilizer. It's heated with 40 cm cube of NaOH and excess. Again, it's in excess. So the fertilizer over here is heated with excess NaOH. Achha, you need to know the reaction. You need to know the equation. Make sure you practice. ये मैंने भेजा था कि नहीं भेजा था ये equations वाला? कहाँ है? Just a second. Where's the? I think. Where did it go? This one. TK. So remember equations. TK, that's moles. It's very important. Because sometimes they'll give you equations, sometimes like in this question, they won't give you equations. So for example, this fifth equation, ammonium salt with a base produces salt, water, and NH3. So I must have practiced this equation somewhere. This is equation number 5, I think. Like after formulas, this is 4. This one, ammonium salt with a base produces salt, water, and NH3. So the reaction is, whenever you have an ammonium salt, any ammonium ion with some random negative ion, that's an ammonium salt. If it reacts with a base, a hydroxide or an oxide, the OH turns into water, the NH4 turns into NH3, and whatever is left, that's your salt, NaCl. Either be the OH and NH4 will turn into water and NH3. PO4 and Ba would be left. That's going to be your salt. So that's a simple reaction. And it's an acid-base reaction. The NH4 plus 1 loses NH plus 1. It turns into NH3. The OH ions, they gain NH plus 1. They turn into water. So it's an acid-base reaction. One of them is losing NH plus 1. This is acting as an acid. And this one is obviously a base. The OH ion accepts NH plus 1. So that is the reaction that's going on. Now, and they're asking for the equation as well. So ammonium sulfate with NaOH, what would happen? First thing, the OH will turn into water. The NH4 will turn into NH3. And what is left? What's left is your salt. That's going to be Na and SO4. So that's Na plus 1, SO4 minus 2. So it's going to be crisscross Na2SO4. You can balance this. It's going to be 2 NaOH. There's probably going to be 2 NH3s because there's 2 NH4s over there and 2 water molecules. So this is your balanced equation. And remember, he added this in excess. This was added in excess. The question then states, where's the question? So the question then states that he's using values as well. 2.96 grams of the fertilizer was heated with 40 cm cube of NaOH. So this is 2.96 grams. And remember, it's impure, it's fertilizer, which contains ammonium sulfate. And this is the volume that's used is 40 cm cube. That's in excess. The question then states that after cooling, the remaining NaOH was exactly neutralized by 29.5 cm cube, 2 mole per dm cube HCl. So this is what's happening. That this is in excess, so there's going to be some leftover NaOH. So there's going to be leftover NaOH, and that leftover NaOH is reacted with HCl, and it produces NaCl plus H2O. The volume of, I think it was, what was the volume that was used? The volume used was 29.5 cm cube, 2 mole per dm cube. So volume is 29.5 cm cube. And the concentration is 2 mole per dm cube. So we've written down the reactions as well. And the whole question is about finding out, and the question does not end over here. The question, so this is the first part of the question. Okay, that part ends over here. Then he does another experiment. And now, if you read on, there's a separate experiment that's going on where 40 cm cube, the original NaOH was exactly neutralized by 39.2 cm cube of 2 mole per dm cube HCl. So he's saying there's a separate experiment. And we're going to make the equation for the separate experiment. So in this separate experiment, the original NaOH, I mean this NaOH over here, the original NaOH, 40 cm cube of it, was reacted with HCl again. Now this experiment has nothing to do with the first experiment. And it reacts with NaCl to produce water. And the volume used was 40 cm cube. That's what they told us. And the volume over here used for HCl was 39.2 cm cube. And I think the concentration that they used was 2 mole per dm cube. Okay, so they had asked for the reactions later on, so I've written down the reactions as well. So that's it. The original NaOH was neutralized by HCl. And now you have to find out, based on this, now you have to find out what is the moles or what is the mass of ammonium sulfate that you have in the fertilizer. So the first thing he's asking in the question is, the very first thing, calculate the amount in moles of NaOH present in the 40 cm cube of the original NaOH. So remember, we are trying to find out the moles in the original NaOH. This is why he did this separate experiment. What we can do is we can find the moles of HCl. वो हम जल्दी से find out कर लेते हैं कि HCl के moles कितने हैं. That's concentration times volume, 39.2 divided by 1000. That's volume in the cube into 2. So what do we get for this?
Zero point zero five nine.
Confirm है 59.
नहीं सर 784 0.0784
0784.
जी सर.
So ठीक है. अच्छा 0.0784 moles HCl के. NaOH and HCl are 1:1. So the moles over here would be exactly the same. It's going to be 0.0784 moles as well. ठीक है. So you're going to get exactly the same moles. अच्छा, so what was the purpose of this second experiment? क्या आपको पता लग गया कि the original NaOH that was added, you know the moles of this now from the second experiment. You know कि ये जो this original NaOH that was point how much 0784 moles. So you know the moles that you added, but it's added in excess. That means जो उसके बच गए ना leftover, that is taking part in this reaction over here. Is that clear? Is the other clear? Is one clear? Amna, is this clear? बाकियों clear है? Sidra?
Yes, sir.
अच्छा, so you found the moles. ये वाले जो moles थे ना, this is why they did the second experiment. अच्छा, anyways, then he's going to ask you to find out the leftover NaOH. This first reaction happened, excess NaOH was added, some of the NaOH was left over, and that was reacted with HCl. So you can find that out by finding out the HCl moles. So if you find the HCl moles, it's going to be वही करना है. क्या करना है? कितना आ रहा है?
0.05
29.5 divided by 1000 into 2. कितना आ रहा है?
0.059
0.059.
ठीक है, तो उसके NaOH के moles would be exactly the same, 0.059 moles. It's 1:1. So anyways, now you found the moles that you added for NaOH initially, जो fertilizer के साथ react कर रहे थे, and you've also found the moles which are left at the end of the reaction. So how many moles actually reacted with this? 0.0784 were added, and 0.059 are still left at the end of the reaction. So कितने moles actually इसके साथ react कर रहे थे with ammonium sulfate? I mean, you're going to subtract the two. What's 0.0784?
0.0194
0.0194
194
moles. Okay, so I'm just going to repeat this. What we did over here is we added originally in excess 0.0784 moles. Some of them reacted with ammonium sulfate, but some of them were left, which were 0.059. So if out of 0.0784, 0.059 are still remaining at the end of the reaction. So that means the amount that is reacting is 0.05194 that's reacting with ammonium sulfate. You're going to subtract the two. And it's 2:1. So according to the ratio, you can find out the moles of ammonium sulfate. So 0.0194, that's going to be divided by 2. And that would give you कितने moles आ रहे हैं इसके?
Sir, 4.85 into 10 raised to power 3.
1 second.
4.85 into 10 raised to power 3 minus 3.
4.85 into 10 to the minus
3.
minus 3 moles. And you found that, and बस बाकी उसने mass का होगा उसके बाद you have to find the mass. So it's going to be moles multiplied by the MR, which is ammonium sulfate, ये NH4 14 plus 4, that's 18 into 2, that's 36. Plus sulfur 32 plus 16 into 4, that's 96. So find, multiply by MR and find the mass. What do we get for the mass?
0.640.
So we are getting 0.640 grams. अच्छा, अब फर्टिलाइजर लिया कितना था स्टार्ट में? Like if you go back, it's a 2.96 gram of the sample. So 0.64 grams we are getting that. So
सर
हाँ जी,
सर आपको 4.85 into 10⁻³ मोल्स कैसे हो गए?
मुझे भी गलत लग रहे हैं। एक सेकंड, ये दोबारा करना। ये तो क्लियर है ना? 0.194 क्लियर है?
हाँ सर वो क्लियर है, लेकिन
उसको फिर
इसका
उसको फिर
मुझे समझ
हाफ,
आया।
हाँ उसको फिर हाफ करना है ना। 2:1 है ना, इनका आपस में क्या रेशियो है? तो उसको हाफ करो ना, हाफ क्या बनता है?
9.7 है सर, वो 4.85 नहीं।
तो ये चेंज करना पड़ेगा।
9.7 into 10⁻³
हाँ, तो 9.7 into 10⁻³, दिस इज ऑल्सो 9.7। तो मास क्या आ रही है अब?
So 1.2804.
1.28। ठीक है, बस आंसर लिखते हुए जो उसने एक्यूरेसी दी हुई है ना, डोंट एक्सीड दैट। ठीक है, मतलब कैलकुलेटर पे
सर जो
इसमें
ये आपने सेपरेट एक्सपेरिमेंट किया, इसी से आपने वो NaOH के मूल फाइंड आउट किए?
हाँ उसने कहा था
मतलब
कि उसने सिर्फ कहा था कि देयर इज एन एक्सेस ऑफ 40 cm क्यूब ऑफ NaOH यूज्ड, राइट?
जी सर।
फिर उसने कहा था कि इन सेपरेट एक्सपेरिमेंट वो सेम जो एक्सेस 40 cm क्यूब नहीं है, उसको रिएक्टेड विद HCl। तो उधर से हमने भी फिगर आउट कि वो जो एक्सेस में हमने यूज किया था ना, वो कितने मोल्स थे? 0.0784, वो यहाँ से आया था ना।
ठीक है, और वो जितने यूज हुए थे वो तो मतलब इससे कम थे?
हाँ, क्योंकि वो फिर लेफ्ट ओवर थे ना, वो फिर दोबारा जो उसमें बच गए थे, द रिमेनिंग NaOH वाज देन रिएक्टेड विद HCl, उसके भी मोल्स पता
मतलब
थे।
जो इन्हें सेपरेट एक्सपेरिमेंट है उसमें सारे ही मतलब यूज हुए हैं ना, मतलब
हाँ
एक्सेस वाला
हाँ,
सारा यूज हो गया?
मतलब सेपरेट एक्सपेरिमेंट का उस पिछले वाले से कोई ताल्लुक नहीं है। ठीक है, सेपरेट में कि उसने
ठीक है।
वो सारा NaOH उठाया और सारे को
ठीक है।
रिएक्ट कर दिया HCl के साथ। सो तो वो उससे हमें टोटल मोल्स पता लग गए थे कि हाउ मेनी मोल्स ऑफ NaOH वर एडेड। वो जो 40 cm क्यूब था ना, उसका ना 0.0784 मोल्स थे। वी फाउंड इट फ्रॉम दिस सेपरेट एक्सपेरिमेंट। ठीक है,
ठीक है। ठीक है। ठीक है सर।
अच्छा बाकी वो परसेंटेज प्योरिटी निकाल लो कि वो फर्टिलाइजर की मास दी हुई थी। मतलब अमोनियम सल्फेट इज 1.28 ग्राम्स, फर्टिलाइजर इज 2 पॉइंट, मतलब क्वेश्चन में ना द फर्टिलाइजर दैट्स यूज्ड इज यहाँ पे इट्स 2.96 grams। तो यू कैन फाइंड द परसेंटेज नाउ कि उसकी परसेंटेज कितनी बन रही है।
तो परसेंटेज 43.24।
ठीक है, अब पता नहीं क्यों ये लग गलत रही है, क्योंकि यूजुअली देयर आंसर्स आर 70 80 90%। तो 40% मे बी दैट्स करेक्ट, लेकिन वी कैन क्विकली।
सर मार्क्स स्कीम चेक कर लें।
हाँ वही मैं कह रहा हूँ, S13 QB21, जस्ट अ सेकंड। (9701) is अच्छा, कौन सा क्वेश्चन था? S13 QB21। ठीक है, हमारा कितना था? 43।
0.43 है।
सर
तो वही मतलब एक मिनट से, वो मेरा दूसरा
सर
कैलकुलेशन मेरा आंसर
43.25 था।
ठीक है, तो उसको राउंड करो, 43.3 हो जाएगा ना। ठीक है, तो इट्स गोइंग टू बी 43.3। इसमें हमारी वैल्यूज तो कोई चेंज नहीं हुई। इट्स ये हमारी क्या वैल्यू आई थी? इट्स 1 पॉइंट।
या सर एग्जैक्टली यही आया था।
अच्छा सॉरी, वो 0.1 यहाँ पे मसला आया हुआ है। रिमेंबर, बी केयरफुल, बी वेरी केयरफुल व्हेन यू कैलकुलेटिंग MRs। ठीक है, मेक श्योर ये तो मैंने मेमोरी से करा था make sure कि when you're calculating the MR, so sulfur is actually 32.1, not just 32. So make sure you take the most accurate values जो उसमें it's given in the pure table. ठीक है, so remember magnesium 24.3 है, calcium 40.1 है. So make sure you, because उसमें ना फिर decimals में you might lose marks for that. क्योंकि एक भी अगर decimal गलत हो जाए ना कहीं पे, so it just the error gets carried forward, और end तक ना the variation becomes much bigger. So make sure be as accurate as possible. तो यहाँ पे ना we made a small mistake. Sulfur is 32.1. So which is why our answer is slightly deviating, very slightly. ठीक है, is this clear? This one?
Yes, sir. Sir,
हाँ जी.
सर अगर हमारे डेसिमल का फर्क आ जाता है, मतलब हमें एग्जैक्टली एमआर याद ना हो, तो क्या एग्जामिनर इसके मार्क्स
नहीं
डिडक्ट करेगा बेस्ड ऑन आवर वर्किंग?
नहीं, याद किया, वो तो सामने दी हुई है, उसने प्योर टेबल होगा. तो अगर 32.1 है और you're using 32, तो he's going to, मतलब he can cut marks for that. Depend करता है question to question, because different questions are answered differently. लेकिन बहुत सारे जो एग्जामिनर रिपोर्ट्स होते हैं, they cut marks for very small things. ठीक है
सर.
हाँ
सर, और आपने क्या कहा था कि इन क्वेश्चंस का मेन पार्ट क्या होता है, लाइक कंफ्यूजिंग पार्ट जो होता है?
वो तो वही होता है ना, one equation to the other equation, right? I told you one thing, that let's say you're given these two reactions, right? तो remember कि इसका जो रेशियो है ना 2:3, that's got nothing to do with its ratio. मतलब इन दोनों का आपस में it's not their ratio. ठीक है, just make sure कि don't start comparing two equations and their ratios. कि जिस तरह अगर if I go back to the previous question, some people, the mistake that some people make is they found ammonia over here, they found the moles of ammonia over here. तो वो यहाँ पे देखते हैं कि यहाँ पे 3 है, तो वो कहते हैं 2:3. They start using ratios, right? So remember, it's this 3 and this 2, they don't have anything to do with each other. ये 3 जो है ना, it's a relationship between the substances in the equation. समझ आइए बात?
यस सर.
ठीक है, इसका और इसका आपस में 3:2 नहीं है, बल्कि इसका तो 1:1 ही होगा, क्योंकि जो अमोनिया यहाँ पे प्रोड्यूस हुई है, वो अमोनिया सारी यहाँ से आई थी. तो अगर यहाँ पे 0.0176 मोल्स है, तो वहां भी 0.0176 मोल्स होंगे. ठीक है, तो ये कंफ्यूजिंग पार्ट होता है. सम पीपल, आई मीन दिस इज द मोस्ट कॉमन मिस्टेक्स आई सी, कि व्हेन दे मूव फ्रॉम वन इक्वेशन टू द अदर इक्वेशन, तो वो देखते हैं यहाँ पे 2 है, वहां पे 3 है, बिला वजह बीच में रेशो लगा देते हैं. जस्ट रिमेंबर कि इट्स नॉट, आई मीन दिस 3 हैज नथिंग टू डू विद दिस 2. ठीक है, दिस 3 हैज एवरीथिंग टू डू विद 18, विद 5. इनके साथ उसका रेशो है. ठीक है, इसके साथ उसका रेशो नहीं है. तो जस्ट मेक श्योर यू रिमेंबर दैट विद इन इक्वेशंस बीच में रेशो नहीं लगाना. ठीक है, so let's do a smaller question. बल्कि एक ना वो I'll send an assignment. एक second, hopefully I have. अच्छा, I'll post an assignment. ठीक है, अगर मुझे क्वेश्चन जल्दी से मिल जाए. just a second. So this is $39. Just hold on 1 second. ये लिमिटिंग एक्सेस वाले क्वेश्चन है. ठीक है, अच्छा नहीं भाई, just 1 second. ये नहीं तो सिंपल है. So solutions, gases. Oh, volumetric analysis, just a second. इसके अंदर 3-4 क्वेश्चन इस तरह के डिफिकल्ट which you should try. ये चारों बल्कि ठीक है. So I'm posting these questions as an assignment. ठीक है. I'll post this in Google Classroom as well. Try and solve, and remember you have to be good with equations as well. You have to learn how to make equations. इसी तरह के questions हैं. ठीक है. And remember you have to be good with this, because if you get this question, it's a 10-15 mark question and you're structured, so that carries a lot of weightage. So try attempting these 4 questions. ये मैंने इसके ऊपर post कर दिया. I'll post it in Classroom as well. ठीक है. चलिए attempt करना है, इसको solve करना है, मुझे send करना है. All 4 of them. ठीक है. Although इसके अंदर तो वो बस एक problem statement लिखी हुई है, but इस तरह के जो questions है ना, like the ones, I don't know if you can see this on your screen, this one. The question would be spread out. वो parts के अंदर जिस तरह के भी हमने question किया ना, it's going to be very similar to this. So try doing these questions. और मैं classroom के ऊपर भी post कर रहा हूँ. ठीक है. चलिए ठीक है. Let's continue tomorrow then.
सर
हाँ जी.
सर ये आज का लेक्चर अपलोड कर सकते हैं?
मैं कर देता हूँ. कल ही होगा, क्योंकि अभी वो प्रोसेस करेगा फिर, तो कल मैं भेजता हूँ लिंक. ठीक है. ओके देन. हाफिज.